Most of you are done there. If you're still finishing up, that is perfectly fine. It's going to ask us now to find outputs from equations. So this little function box might go away, a little less words, and you'll just get an equation, which I don't think is any different. This one is saying that we are going to plug in these inputs. It is a side length of a square. The output is its area. So if you have a side length of 8 on a square, Adam, what's its area? Like 64 is correct. 8 times 8, 8 squared. Okay, how about 2.2? 2.2 times 2.2. Again, do it by hand or use a calculator. 12 and a fourth. So you can use a fraction if you want to use maybe the Desmos calculator to use that, or you can do 12.25 times 12.25 and put it as a decimal. It don't matter. Somebody give me that? 150 and a 16th. Or you could do the decimal equivalent of that. That would be fine as well. How about if the side is s? What's s times s? S squared, absolutely. And then that's the equation, right? Side squared to get the area of a square. Next page. Next page says we're going to match each of these descriptions with a diagram. So we see a lot of diagrams there on the right. We see some descriptions. We're just going to match it all. I'll show you this. You can kind of just look at the diagrams there on the left. So description A. Okay, the circumference of a circle with radius r. So which formula is circumference of a circle? Do you remember that when you worked on circles last year? One of these is circumference of a circle. Yeah, right, here's the circumference. So I'm going to match that. That's description A, and that is diagram D. Then it says, what is the equation? Well, it tells us that in a box. The equation for circumference is 2 pi r. Diameter times pi, 2 radius times pi. Tells us that right here. Now, if the input is 5, what's the output? Well, so if I plug in 5 here, 2 times pi times 5. Remember what we used for pi? 3.14. Okay, so 2 times 3.14 times pi. Or sorry, times r. R we said was 5. 31.4. Technically, you could have left it as 10 times pi as well. 10 times 3.14. Either one would be fine. So what letter is the independent variable? What is my input letter? R. And what is my output letter, my dependent variable? C. Done. Okay, let's move on to description 2. The distance in miles that you travel in T hours if you drive 60 miles per hour. That's going to be letter B right here. If I go 60 miles an hour for 1 hour, I will make it 60 miles. 60 miles an hour for 2 hours, I will make it 120 miles. That is B. The equation, again, it tells me. So Parker, if the input is 5, if I drive 60 miles an hour for 5 hours, I will drive how far? 300. Parker. 300. 60 times 5. 300 miles. Ian, what's my independent variable? The input letter. T. Output letter, Taylor? D. All right, I want you to see if you can do this one by yourself. Match it up with the diagram. Again, the description's on the left side, the left page there. See if you can fill it all up. All right, who wants it? Wyatt, thank you. All right, what diagram? Well, A or C are your choices.
Let's see.
C. Equation?
Yeah, transfer.
And if I plug in 5, take it times 3 and subtract 4, I get?
11.
Yes, sir. Independent variable?
X.
Output?
Y.
I'm thinking I won't even have to make a video tomorrow. I'll be gone. I'll just let you teach the class. What do you think? Ready for it?
No.
No? All right, last one. Of course, that means it's A. Equation is the side cubed. Input 5 cubed. 5 times 5 times 5. Input? Output? Perfect. All right, I think we're going to skip the Are You Ready here and get into the last question. Gavin, would you read the directions for 3.3, please?
Judah had some dimes and quarters that had a total value of $12.50. The relationship between the numbers of dimes, D, and the numbers of quarters, Q, can be expressed by the equation 0.1D plus 0.25Q equals 12.5.
All right. So 1250, that's a big thing to know here. We don't know how many of each we have. We have to figure that out with some of these questions. So if I have 4 quarters, how much is that worth? Obviously 4 quarters is $1, right? That means my dimes have got to equal $11.50.
That's a lot of times.
Because I have 1250 total. So how many dimes would it take to get $11.50? What's that? 115 is correct. All right, take that divided by 10 cents. Okay, how about if I change to 10 quarters? Well, how much are 10 quarters worth? So if 10 quarters are worth $2.50, that means my dimes has to be worth $10. So that would be 100 dimes. Question number 3, is the number of dimes a function of the number of quarters? If yes, write a rule. Okay, well, to get the number of dimes, I'm taking $12.50 minus my value of the quarters. All right, now why is it a function, right? Well, if I have 4 quarters, there's only one answer I can get for the number of dimes. It ain't going to change each time I do it. It's going to be the same. Now, if I change the number of quarters, that changes the number of dimes, but there's still only one answer. All right, question number 4. If Jada has 25 dimes, again, how much is that worth? That's $2.50. That means I gotta have $10 worth of quarters.
So 40 quarters.
40 quarters. It's a roll of quarters, in fact, worth $10. 30 dimes. Obviously, that's $3. $12.50 minus $3 means I have $9.50 worth of quarters. 30 what? Well, it's 2 less quarters than you had the one before, right? It's 50 cents less.
36. 36.
It's 38. It's 2 less quarters. All right, it went down 50 cents. That's 2 quarters. Don't overthink it. Now, is that a function? If I have a certain number of dimes, does that mean I can only have one answer worth of quarters? Yes, it does. Again, I'm taking $12.50 minus dimes are worth 10 cents. I suppose I'm also dividing by their value. $12.50 minus $3 would give me $9.50, so I would have to take this divided by how much a quarter is worth. I would have to take this divided by how much a dime is worth. Those would have to be added there. Otherwise, it'll just be value. All right, bottom of page 26, just a summary. Okay, area equals pi r squared. What is that the area for, just out of curiosity? Circle. Pi r squared is the area of a circle. Remember, this is your input, your independent variable. This is your output, your dependent variable, your y. Okay, the same thing can be shown in a function form, right? The function diagram, they show you the same thing here. Probably easier to see that it's the input there, but it is the same thing, same letters, whether you write an equation or not. Input and output. All right, take a look at your homework. Question number 1, which ones describe the same function? So which ones could you multiply all these things by the same thing, or divide by the same thing, or rearrange it that it's the exact same equation? And it does say select all, so that is going to mean there's more than one answer there for you. Question number 2, draw a graph and write the equations of lines with no solution. Do you remember what it means to have no solution? They will be parallel lines. So you're going to draw 2 parallel lines, and then you're going to write the equation of 2 parallel lines. And there's a spot for you to graph them on top of page 29. Question number 3 is going to be similar to what you did today with writing the equation. It's just going to give it to you in paragraph form here. It says going to rearrange, so the letters you're going to do are R for pounds of rice and B for pounds of beans. So write any equation you want based on this information, like you did the quarters and dimes. And then B, it says write it so that B is the independent variable. That means you're going to have to solve for R. All right, so R is the output. And then the other one is the exact opposite. You're going to solve your equation for B. Okay, the last one. Okay, again, solving. A is a whole number. B is a fraction or decimal. C is a whole number as well. And B is probably the easiest, but unfortunately it doesn't come out to be the nicest number. It's a fraction. And there's a couple different ways to do A and C. So again, just try those, try to solve them. We will go through them tomorrow. So just 1 through 4.